Hello, I'm Sriniti from MTech Integrated CSC. So, I'm going to speak on the topic the role of cryptography on blockchain and Bitcoin. So, cryptography is the science of protecting information through mathematical techniques that make data secure and unreadable to unauthorized users. So, blockchain, on the other hand, is a distributed digital ledger that records transaction across multiple computers in a secure and transparent way. The connection between these two is very strong. Blockchain relies heavily on cryptography to ensure security, integrity, and trust of every transactions. Without cryptography, blockchain and cryptocurrencies like bitcoins would not be able to function safely or reliably. So, cryptography plays a crucial role in blockchain because it ensures that all data and transaction remain secure and trustworthy. It maintains data integrity by preventing anyone from altering or tampering with transaction records. It also provides authentication, which helps confirm the identity of users and nodes participating in the network. So, cryptography ensures privacy by protecting sensitive transaction details from being exposed to unauthorized parties. Lastly, it enables non repudiation, meaning once a transaction is recorded, the sender cannot deny having made it. Altogether, these features make cryptography the foundation of blockchain security. Now let's see about the cryptographic techniques used. So blockchain uses several cryptographic techniques to ensure security. The first is hashing, which converts data into a fixed length code. This helps detect any changes in the data, ensuring integrity. The next is the digital signature, which verifies the authenticity of transactions and confirms the sender's identity. Finally, public key cryptography. It uses a pair of keys, one public and one private, to encrypt and decrypt data, enabling secure communication between users. Together, these techniques make cryptography and Bitcoin safe and trustworthy. Now let's see about how blockchain uses cryptography. So basically, blockchain uses cryptography to securely link blocks of data together. Each block contains transaction data, the hash of the previous block, and its own unique hash. This structure forms a continuous and secure chain. If any information in a data is altered, its hash changes, which immediately makes all the following blocks invalid. This cryptographic linking ensures that the blockchain remains tamper proof, maintaining the trust and integrity of the entire system. Now let's see an example for Bitcoin. So Bitcoin is a great example of cryptography is applied in the blockchain. It uses digital signatures, especially the elliptic curve digital signature algorithm, to verify that transactions are genuine. Each Bitcoin wallet has a private key that is used to sign and authorize transactions securely. Meanwhile, miners use cryptographic hash function as a part of the proof of work process to validate transactions and add new blocks to the blockchain. Together, these cryptographic methods keep the Bitcoin network secure and trustworthy. The advantages of the cryptography in blockchain. The use of cryptography in blockchain provides several important advantages. First, it makes the system secure and tamper proof, as any attempt to alter data is immediately detected. Second, blockchain is decentralized, which is there is no need for a central authority to manage or control transactions. It's also transparent and verifiable, allowing anyone in the network to confirm transaction independently. Finally, it builds trust among users without relying on intermediaries like banks, making the entire process more efficient and reliable. So let's see about the blockchain and its transparency. Blockchain promotes transparency because it works as an open ledger where all the transactions are visible to every participant in the network. This openness creates accountability since every action can be traced and verified. By making records public and tamper proof, blockchain greatly reduces the chances of corruption or data manipulation. In this way, cryptography and transparency together help build a system that people can trustworthy. Let's see about the challenges and the future outlook. Despite its advantages, blockchain still faces several challenges. One major issue is scalability. As the number of transactions increases, the network can become slower and more resource intensive. Another challenge is regulation and compliance, as governments are still working to create clear legal framework for blockchain and cryptocurrencies. Energy consumption is also a concern, especially with systems like proof of work. So, looking ahead, the future of blockchain is promising with trends such as green blockchain solutions, which aimed to reduce energy use, and also improved interoperability that allows different blockchain to connect and share data, and mainstream adoption across industries like finance, healthcare, and supply chain management. So, in conclusion, cryptography is truly the foundation of blockchain and Bitcoin. It ensures that every transaction is secure, verified, and cannot be altered. Building trust in decentralized system without cryptography, blockchain would simply be another database, not the revolutionary technology that's transforming the way we store, share, and protect information. Thank you.